Good morning, Master. My name is Sonozaki, and I'm 5A, number 80. So my topic is about electromagnetic induction. To start with, we need to talk about who has discovered electromagnetic induction. That is Michael Faraday. He had discovered the electromagnetic induction in 1831, and he discovered when he was putting the coil of wire and he prepared two of them, and then he moved each other, and he found that there is the electromotive force produced by movement of the magnet. So um, he is said to be the founder of the Faraday's law of electromagnetic induction. Um, the importance of electromagnetic induction is that um, when magnetic field is applied to an conductor, it will produce EMF, and on the other hand, if the conductor has EMF, then it could produce magnetic field. So that's the main concept of electromagnetic induction. So the formula we have is E. This is EMF is equal to minus magnetic field length, the velocity of the conductor, and the sine angle between the magnetic field and the conductor. And another formula, E is equal to minus N, which is the number of turns in the coil, and this is the change in magnetic field times the area VA, delta VA, and this is delta T, which is the change in time. So to explain, we have two diagrams. This is transformer, this is galvanic voltmeter, which is used to measure the voltage produced, EMF produced. So in this case, we have a magnet, north pole and south pole. So we know that a magnetic field is produced from north pole to the south pole. So it's like this and this. So as we move this one left and right, then the magnetic field, this magnetic field will cut the conductor, so it will produce the EMF in this coil. For this one, when the current passes through this wire, this coil, then it means that we can say the current produced magnetic field inside here. Therefore, magnetic flux is flowing through this iron core, um, which is induced by the magnetic field from the wire. In this case, we have magnetic field, but we also have what's called eddy current, which is the term used to explain the current that opposes the magnetic flux, and that is where the power is dissipated by the transformer. So this is this eddy current is explained by law of conservation of energy, which means when the magnetic flux is flowing through, then we have the eddy current, which is opposing the magnetic flux. Okay, so we move to the Lenz law, which is another concept by Lenz. It says that the current is produced by the magnetic field which opposes the charge. So to explain this statement, which is a bit complicated. We have solenoid and the iron bar in the middle, and then we have the magnet here. So as I told you before, we have the magnetic field flowing this way, and the force here means you are pushing the magnetic towards to the solenoid or the magnet iron core. And when it stays still, the magnetic field is flowing this way because this has the magnetic field this way. So this is the ordinary one. So when we push this one, we have another increase in magnetic field, which is the delta V, and that delta V is causing the induced magnetic field in the other direction. So this means that whenever the magnetic field is changed, then the induced magnetic field is in the opposite way. So it is stated by here. The current is produced. So the current is produced means this induced magnetic field will cause the current in here using the right hand rule. So when the induced magnetic field is inside to the solenoid, then we take this one, we take it like this way, so the current is going down. So in this wire, we're gonna zoom in. So we have the iron core, and then we have the wire. So the magnetic field is to this way, so it is inside the iron core. So we think that magnetic field is going inside, so we know that current is going down. So I is going down. So that's the most important things about magnetic induction.
Hello, Masadan and my friend. Today, my name is Chang. Today we talk about magnetic flux. Magnetic flux is a measurement of the total magnetic field which passes through the certain area. If we use the field line picture of a magnetic field, then every field line passed through a given area contributes some magnetic flux. Magnetic flux have the equation for BA cos theta. B is magnetic field unit Tesla. Magnetic flux, the SI unit is Weber or VB. A is the area for the thing that magnetic pass through. Okay, this is the picture, and this one is another one. The theta or the angle will be the normal line that perpendicular to the magnetic field. Okay, now we will look the example. Okay, this example. If there are two plates placed in the same magnetic field, first is perpendicular to magnetic field and second is placed in 37 degrees to magnetic field. Which is the ratio of magnetic flux between first one and second one? First, we use the equation flux equal magnetic field times area times angle. For the first one, we use flux 1 equal B times A times cos theta 1. Okay, now the theta will be 0 because it's lie on the normal line that perpendicular to magnetic field. So cos 0 is 1. So first flux equal BA. Now the second one is flux 2 equal BA times cos theta 2. Flux 2 equal BA times cos 37. Cos 37 is 4.5. So flux 2 equal 405 BA. So the ratio between 1 and 2 we will get flux 1 over flux 2 equal BA over 4 over 5 BA. So we'll get that flux 1 over flux 2 will get 4 over 5. Okay, now we are in exercise number 2. The question is a magnetic produces a magnetic field of 180 micro Tesla through a regular region of 30 mm times 40 mm. Measure at right angle to the field, find the magnetic flux. First, we write down the equation. Equation is flux equal magnetic field times area times angle. First, the magnetic field is 180 times 10 of minus 6. Minus 6 comes from the micro. Micro is 10 minus power of minus 6. Second one is 30 millimeter equal 30 times 10 of minus 3 times 40 millimeter is 40 times 10 of minus 3. So we get 1200 times 10 of power minus 6, or about 0.0012. The angle is 0 because it says that it's right angle to the magnetic field. So cos 0 is 1. So we use this to the equation, apply this to equation. B equal to 180 times 10 minus 6 times 1200 times 10 of minus 6. The answer will be 0.15 Weber. Thank you.
Electromagnetic induction. To understand this, we have to understand magnetic flux. And what is it? It is how the conducting material is affected by the magnetic field. What do I mean? I mean, if there are change in magnetic flux, there also a current produced. Two variation. Magnetic field and surface area. I'll be using conducting wire. Here is a picture of magnetic field and a conducting wire. If I increase the strength of the magnetic field, there is current produced. And if I change the angle of the conducting wire, there also a current produced. I will create a simple generator by using a magnet and a conducting wire which connected to a galvanometer, which indicates the current, amount of current. If I move the magnet in, there's a change in the galvanometer, and if I move it out, there's a change in galvanometer. But if I set it stationary, there's not going to be any change in the galvanometer, which is there is no current moving in the wire. So how are we going to make this magnet move? Yeah, we use sources of mechanical energy, and then we use this magnetic induction principle to create current moving in the wire. Thank you. My topic for today is electricity generator. What is it? It's a device used to convert mechanical energy to electricity energy for use in external circuit or into a device, electrical device, any device use electricity. Mechanical energies could come from steam turbines, gas turbines, water turbines, some internal combustion engines, which I'll be picturing the diagram to be easily understand. This for the water turbine. Water coming here and get on here. Yeah, it's a resource, and then it generates mechanical energies for generator, and then it connect to maybe a light bulb. Yeah, listening to the chip. Yeah, it's a simple diagram for electricity generator. They fall into two broad categories: dynamos and alternative. Dynamo. What is the difference? Yeah, they work based on the same principle, which is electromagnetic induction. But in dynamos, they create direct current, which is the D. Yeah. In alternative or generator, they mean the same term as the alternative. They, yeah, A, create alternative current. We will explain how it works in the next part.